Hi everyone, my name is Benjamin, and in today's video I will cover how you can land transactions extremely fast using our LightSpeed network. So we are going to talk about how to use this tip-based service and land transactions as soon as possible, how LightSpeed compares against regular staked and unstaked RPCs, and eventually how we can apply this when buying an actual token. And on top of that, all the code will be available for download via our GitHub repository. For more information, you can always check out our docs, and if you're interested in live metrics, consider joining our Discord server. Both links will be in the description, and with that said, let's get started. Alright, so here within our documentation, you can see that we partnered with a large pool of validators to provide our staked RPC users an additional option to land transactions even faster via our LightSpeed network. And it is a tip-based service that will allow us to land these transactions as soon as possible. Of course, as it is a tip-based service, larger tips translate into faster transaction processing times. Now, the minimum tip required is 0.01 sol or 1 million lamports, and what we will have to do is append this LightSpeed parameter to our staked RPC URL. And again, if you want real-time metrics, you can find them here within our Discord, and the tip address that we need to use is also mentioned here. So what we will have to do is append this LightSpeed parameter to our endpoint URL, and then we will also have to include a transfer instruction to transfer the tip to this address here. And then we can set up a RPC connection, and we will have to set up a separate RPC connection just for sending transactions, because this endpoint, if we are using LightSpeed, will only allow the send transaction and the get held RPC methods. So we can find multiple examples on how to implement that over here on our GitHub. So here you can find an example on how to play around with LightSpeed, how to implement it. However, for today's demo, we are going to use a other repository within Solana Vibe Station. You can also download this, and we are going to use MemoBench gRPC library, which will allow us to send transactions and also see how fast they land. There will be a gRPC connection that will listen to all the transactions from our account, and then this library will also send these transactions for us, and while it listens for these transactions, it will see how fast they are landing. Now, the only thing that we need to do is pull this repository, make some slight changes to make sure that we add the instructions to send the tip, and see how fast these transactions actually land. And we are going to compare staked RPC versus non-staked RPC, and also the staked RPC using the LightSpeed parameter. Alright, so I pulled this repository on my computer, and the next thing that we need to do is make sure that Go is installed, as this is written in Go, and you can do that by typing Go version, and then you will see the version of Go that is installed on your computer. Now this is written in Go, and in order to build this binary we need Go, and you can get Go by going to go.dev/dl, or you can just go to go.dev and then click on the download button. Now once it is installed, you will see that you can run this command and you will see the version that you have installed. The next thing that we need to do is compile this program, or compile this binary, and again it is also written in the documentation how we can do that, and we will also have to create a configuration file. And building the binary we can do by using this command here. So if we go back to our program, what we will have to do is go build and then provide these flags as was written in the documentation, and then we can specify the name that we want to output it, and also where we can find the main.go file. Now I'm within the build folder, as I will put the build in the build folder, and if I do this, this will create a build from that binary. If I then open the build folder here, you can see that I have now this memobench-grpc.exe, and I can execute this, and I also created a config file here which is based on this config.example. Now as I said earlier, I made some slight changes to make sure that we can provide the tip and also the tip address, and that we created the instruction to actually send the tip, and I also made sure that we can add the amount of tip and the tip address within the config file. Now this is written in Go, so if you're not familiar with Go, you can use some kind of AI agent and make sure to apply these changes, but I will show you real quick what I did. So within the main.go file, I added an extra package which is the solana.go or solana-go/programs/system, and the next thing that I did is expand this config, as you saw, where we will add all this information, and I added a tip amount and a tip address, and I did the same for the config struct, and here you can see the tip amount and the tip address, so it represents these two values that I have added. And then a bit down here you can see that I actually added the instruction which will send that tip to that tip address, and this will be included in the instruction eventually that we are going to send. And based on that, I created a new config file here, and if you look at that config file now, you see that there is a tip amount and a tip address, and this is needed if we want to use the staked RPC endpoint using the LightSpeed flag or the LightSpeed parameter. And if we set this to null, it will of course not send a tip, and then it will complain like, hey, we need a tip. However, if we take away the LightSpeed parameter, then it should be okay without a tip, and that is what we are going to test now. Alright, so in order to test this, I have access to a HPC VPS from Solana Vibe Station. And as you can see, I'm connected to this VPS, and I'm currently in the home vibes / memobench grpc / build folder, that folder that we created here earlier. And if I go back one level, then you will see that we also have all these files here that are within our project here. So I just copied over all these files from our local machine into our VPS. And I did that by using the command scp-r, copying all the files within this directory, and then I used SSH to connect to that machine and copy all the files within the home vibes memobench grpc folder. And what we can do now is update the config.json file, rebuild the program, and then run it within this VPS. So if I clear this terminal real quick, what we can do is go back to our build folder and cat our config.json file real quick. And what you can see here is that we have set up our send RPC URL using the LightSpeed parameter. And we also provided a tip from 0.001 Solana, and we specified the tip address. So what we can do now is make another build, and we can use the same command, go build, then the specified flags from the documentation. And this time we will specify the name as memobench-grpc without the .exe of course, and where the main.go file lives. And if we run this command, it will also create that file for us. And if you can see here under the build folder, we have now this memobench-grpc. So what we can do now is just run this memobench-grpc file. And then that should start the tool, send the transactions, and see how fast they land. So if we just execute this, we get a nice overview of the setup that we created in our config.json file. We have a small delay, and then you can see that all the transactions have been sent. And then we get a nice overview, and we can see how fast these transactions are actually landing. So we sent 10 transactions, and this is the rate limit. And we also can see how fast they were landing on average. So on average, the transactions landed in about 70 milliseconds, and the fastest one was around 68 milliseconds. So that is quite fast. So what we can do now is change the parameter and remove the light speed and the tip, and see how fast that would do with a regular staked RPC. So what we will do is just remove light speed, but we keep the actual API, and we will also remove the tip, and we will set the tip to 0, just like this. And then we can write and save this file. And if we now run this tool again, it should pick up our new configuration, as you can see here, without the light speed, and then also that small delay, sending these transactions again. And here you can already see that the transactions landed much slower than when using the actual light speed parameter. So on average, we landed around 752 milliseconds, and the fastest was 682 milliseconds. And also here you can see that we consumed 2 blocks. So if we run this once again, we can see if this was a one-off or that we are really much slower than using light speed. And also here we are much quicker than before, but not nearly as close as when we were using the light speed parameter. All our transactions landed above 100 milliseconds, and using light speed, this was under 100 milliseconds. So we can see much better landing time using the light speed parameter. Of course, just out of curiosity, I just want to set up the config using a unstaked RPC and also see what results we get there. Alright, I now set up the regular unstaked RPC within our config file, and if we run this tool again, you can see that it's now using the unstaked RPC. We have that small delay here again, and once again the transactions are sent, and also here you can see that we have much slower landing times, above 1000 milliseconds even, so it takes us longer than 1 second to actually land on average. Our fastest transaction was 786, but also here you can see using a unstaked RPC is much slower than using the staked RPC, and it is uncomparable if we would use the LightSpeed parameter. So as you can see, using the LightSpeed network really helps us landing these transactions as soon as possible, under 100 milliseconds, compared to using a unstaked RPC where we land the transactions over 1000 milliseconds. And even if we use this staked RPC, we could not land these transactions as fast as we did with the LightSpeed network. So this comparison shows us that LightSpeed really helps us landing these transactions quicker. And the next thing that we are going to do is apply this into a real world use case. We are going to set up a gRPC stream, look for migration events, and once we capture these migration events, we are going to use the internal Pump SDK to create a transaction and send off that transaction using the LightSpeed network to see how fast we can actually intercept these migration events and swap a Pump Swap token. Alright, so within this code base, we are going to set up a gRPC stream, and then we are going to listen for migration events on the Pump.fun program. I can show you what I mean. So we have the Pump.fun program here, and if you look, I filtered out all the migrate instructions. And if you look at one of these instructions, then you will see that a migrate instruction has been triggered here. And if you look closer at this migrate instruction, we can look at the raw data, and here you can see the hexadecimal representation of that. And you will see this hexadecimal representation you can also find within the config of our program. As you can see here, our hexadecimal representation is turned into a buffer format so that we can compare it against the data returned by our gRPC stream. And we also have the program here that we want to look into. If we have a look at our index.ts file now, here you can see that we set up a gRPC stream. And if you have a look at the start gRPC function, then you can see that we set up a client using the gRPC endpoint and the gRPC token. And then we will create a gstream using our gclient and the subscribe method. And then we will also create a gRequest object, and that object has been returned by the return subscribe requests. And this function will just return the object to us that is needed to subscribe to this gRPC stream. As you can see here, we are mentioning the program ID that we want to look for. What we will do next is create a try catch statement, and within this try catch statement we will create a function called send subscribe request. What this will do is take that stream and that request and send it, and for that we have a separate function, and we promisify this function, meaning that it will return a reject or a resolve. And this function will just take that stream that we provide and send this request that we provided to make sure that we are now listening for that Pump.fun program. And this is wrapped in a try catch statement, meaning if something goes wrong, if this is not resolved properly, an error will be thrown. If everything goes well, then we will output the message subscription request sent successfully, and we will try to create the listeners for our stream. Also for this we have a promisified function. So what that will do is take that stream and create the event listeners in case the stream closes, in case it ends, and in case there is an error. The most important listener here is the data. So if data comes through, then we will parse it to the handle gRPC data function, and that function is also declared here. What we will do first is check if the data that has been returned is a valid gRPC object, and for that we have a function. And what we will do here is parse the data and just make sure that the object or the data that has been returned contains all these values here. If that's the case, then it will return true to us. Next, we will extract some information from that data that has been returned to us, like the transaction, the message, the instructions, and also the recent block hash. And then we will make sure that we have all this data before we continue. The next thing that we will do is see if we can find a matching instruction, and for that we look at the instructions that we extract from the data that has been returned, and then we have a function for that matches gRPC creation data. So what this does is looking at the program instruction, and then at the instruction, remember in our config we provided the instruction in buffer format, and this comes from the hexadecimal instruction data that we found on Solscan. So if you go back to our index.ts file, what we will do here is check if this instruction data equals to any of the instructions within our data that was returned from our gRPC. And if that is the case, then we will return true. If we return false, then we will not continue, because then it's not the instruction data that we are looking for. So in other words, it's an event within the Pump.fun program, but it's not a migration event. However, if it is a migration event, then we will continue and extract the index values for the pool key and the mint key. And then we will take these account keys, and based on these account keys and the indexes, we can extract the pool public key and the token public key. Next, we will check if we are already handling this mint address, because the gRPC stream might send us multiple migration events for a certain mint. If that's the case, then we will just return false because we don't want to buy a token multiple times. If not, then we will continue and make sure that we add that mint to the processed mints array. So next time, if that mint comes along, we will do nothing. Next, we will make sure that we have a swapper instance, and this instance is created with the init pump swapper function. So this function will be called, and if everything goes well, it will start the gRPC. We can have a quick look at that. So this swapper instance is set by creating a new instance from our pump swapper class, and this pump swapper class is the class that we created to do the actual swap, and we just provide our staked RPC and our staked RPC that we will use to send the raw transactions, and this will be the RPC containing the LightSpeed parameter. So once we have that instance set up, we will continue. If it is not there, we will of course return false, and then based on that instance we will consume the buy method, and here we will provide the actual pool key that we extracted, the amount of times that we want to retry, and the retry delay, and also the recent block hash that we got returned from our data here as well. Next, we can have a look at the actual functionality that will take care of the buy. So here we have our class, the pump swapper class, remember, and once we create an instance from this class, our constructor will be triggered, and within our constructor we will take the RPC URL and the RPC URL that will contain the LightSpeed parameter, and then we will create two connections, one with the regular staked RPC connection and one with the RPC connection that contains the LightSpeed parameter, and we will also create a key pair from our user, and of course our user details are stored within our environment file, and this is just the private key of our wallet, and then we will output also which RPC endpoints we are using. Next, we will also create an instance from the pump internal SDK and store that within this value here, and these variables are set here on top of our class, and they are set to private because they will only be used within our class here. Next, we have the buy method, which we consumed earlier to make sure that we can actually buy the token, and here we provided the pool key, the max retries, the retry delay, and the recent block hash. And what we will do first is make sure that our pool key is a public key. We will set the fee config public key and the fee program public key. These are needed within our instructions. And then we will create a swap state based on our pool address and our public key. Take that swap state and create a buy quote input. Now, once we have these swap instructions here, we will also add this fee config and this fee program public keys. And then what we will do is create a new transaction based on all these instructions that we have here. What we will do next is add a system program transfer, because that is where we will actually make sure that we send that tip to this address here. Remember, this is the address that we have to send the tip to, the amount of tip in LAMP ports, and who will pay that tip. And in this case, that is also the user which we created based on our private key. And then we will add that to the existing transaction that we created here. We will provide the recent block hash, which we provided once we talked to this method buy, and if it's not there, then we will make sure that we get the latest block hash based on our RPC connection. We will add the fee payer and eventually sign the transaction, and then we will take that transaction, serialize it, and send it using the send raw transaction method. And here we will use our actual RPC connection using the LightSpeed parameter. As you can see here we have the RPC connection v1 sent, and earlier we used the RPC connection v1, and that is because this connection here using the LightSpeed parameter will only allow us to use the send raw transaction method or the get held method or the get held RPC methods. Now, once we send that raw transaction, we will also try to confirm it, of course, and if there is an error, then we will return an error, and if everything goes well, then we will return that signature from that transaction back to our index file, and then we will take that signature and we will output here what token we just swapped. So this is the setup that we will use to listen for these migration events using a gRPC connection. And then we will make sure that we set up a pump AMM SDK instance using our regular RPC or our staked RPC, and then we will create a swap transaction, adding the right instructions, making sure that we add the system transfer to make sure that the tip has been sent, and then we will take that transaction and send it using the LightSpeed RPC connection that we created. Now we will take this setup, also move it to our VPS, run it there, and see how fast we can actually find a migration and swap the token. Alright, so I copied over our project onto our VPS, and I made sure that npm and node was installed. As you can see here, if I run node and npm-v, it will show the exact version. And as a side note, if you want to know how to set up a VPS and make sure that all the ports are open to SSH, and also how to install things like npm and node, check out the previous video where I cover in detail on how to set up a VPS from scratch. With that said, let's continue. So I also made sure that the dependencies of this project were installed by typing npm-i, and now that all the dependencies are there, what we can do is starting this application by typing npm run start. So this in turn will make sure that our RPC connections are set up, both using the LightSpeed one and the regular staked RPC, and also that our gRPC is subscribed to this Pump.fun program, listening for these migration events. So once a migration event comes along, we will intercept that, build the transaction using our regular staked RPC, and then we will send that transaction using the LightSpeed parameter. And after that, we can see how fast we actually intercepted that migration event and how long it took us to swap the token. Let's wait until a migration event comes along, and then we will check out both the event and also the actual swap, and we will have a look at the token itself. Alright, so as you can see here, a token migration came through. Actually, two of the token migrations came through really quick, so let's have a look. And these two tokens just migrated, so we can have a look at both of them. And here you can see that we bought. Let's sell this token really quick, and then we can also have a look at the other one. And also here we bought really quick, I believe. So let's refresh this page so it will show the migration event. And here we can see that the token migrated, and roughly 1 second, max 1 second later, we swapped that token. And also this token, I believe we can sell really quick. So we took roughly 100% profit on this one, and I believe 15% on this one. So let's have a look at the actual trigger of the swap event and the swap event itself. So the first one was triggered by this event. So here we can see that this token was migrated at 8:52:26, and it was swapped like roughly 1 second later. And if we have a look at the second event, so here we can see that this token was being migrated around 8:52:45, and this one was swapped around 8:52:46. As you can see here, this was block 91 and this was block 93. So it's really quick. Of course, there are other factors that we need to take in account. We do some RPC calls in order to build the transaction. However, it still swaps the tokens quite fast after the migration event was happened. And as you can see here also, we find that migration event, and there are like roughly 2-3 attempts before the swap goes through. So that is how we use the LightSpeed network in combination with a gRPC setup to detect these migrations and then build the transactions using a RPC or a staked RPC, and swap the transactions using the staked RPC on the LightSpeed network. Again, if you're interested in the live metrics of this LightSpeed service, consider joining our Discord. The link will be in the description. And with that said, I hope to see you in the next one.